All right, here we go. This is question number 4 from the 2019 Calculus BC exam. That means that it's a calculator inactive question, so put that calculator away. You're not going to get a chance to use it. Here we go. A cylindrical barrel with a diameter of 2 feet contains collected rainwater as shown in the figure above. The water drains out through a valve not shown at the bottom of the barrel. The rate of change of the height h of the water in the barrel with respect to time t is modeled by dh dt equals -1/10 times the square root of h, where h is measured in feet and t is measured in seconds. The volume V of a cylinder with radius r and height h is V equals pi r squared h. All right, they just gave us a ton of information, so let's make sure we read that again. A cylindrical barrel with a diameter of 2 feet. Okay, so here's my cylinder. I know that the diameter is 2 feet, contains collected rainwater. That's going to be the shaded region here. The water drains out, so we're leaving through a valve at the bottom of the barrel. So you can imagine a little like drip, drip, drip happening down here. The rate of change of the height of the water in the barrel with respect to time t is modeled by this relationship dh dt equals -1/10 square root of h. So dh dt is -1/10 times the square root of h. Okay, and height is measured in feet, so the units here are going to be feet. T is measured in seconds, so feet per second. We know that the volume V of a cylinder with radius r and height h is V equals pi times r squared h. You didn't even need to know that. They gave it to you, but you could have figured that out. Area of a circle is pi r squared times the height h. Part A, find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. Indicate units of measure. I want rate of change of the volume with respect to time. That means dV dt when the height of the water is 4 feet. So h is 4 feet. I want to find dV dt when h is equal to 4. Well, let's think about that. I want to know dV dt when h equals 4. I know that for this problem, the volume is pi times the radius squared times the height. Okie dokie. And we've got this cylinder. Well, what do I know about this cylinder? It has a diameter is 2 feet, so that means that the radius has to be 1 foot, or 1 foot. Okay, so the volume in this case is pi times 1 squared times h, or volume equals pi times h. If I want to find dV dt when h equals 4, we're going to find the derivative with respect to t. Well, pi times h, pi is a constant, so the derivative is going to be that dV dt is equal to pi times dH dt. We know that dH dt is equal to -1/10 times the square root of h. If I want dV dt when the height is 4, I'm going to have to come over here and say, well, what is dH dt when h is 4? Well, I'm going to plug that in, -1/10 times the square root of 4. Easy enough. Square root of 4 is 2. -1/10 times 2 is -2/10, or -1/5. So it must be that dV dt is pi times -1/5, or if you prefer, -pi/5. Now let's be careful with the units here. V is volume. Since the height is measured in feet, the radius is measured in feet. This is going to be cubic feet for the volume. T is time, and time is being measured in seconds. So this would tell me that dv dt when h is equal to 4 is negative pi over 5 cubic feet per second. What that would mean is that when the height is equal to 4 feet, when the height of the collected rainwater is 4 feet, the volume is changing. Well, specifically, it's decreasing at a rate of pi over 5 cubic feet per second. They didn't ask us to explain the meaning of the answer in this problem, but they could have, and we would have been ready for that. In terms of points, they awarded 1 point for your recognition that dv dt is pi times dh dt, and then the second point comes from your numerical answer with the appropriate units for a grand total of 2 points. Not too bad. That's part A. All right, let's look at part B. In part B, we're told when the height of the water is, sorry, blurry there, when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing, and we have to explain our answer. So when the height of the water is 3 feet, so h equals 3 feet, is the rate of change of the height of the water. Well, rate of change of height of the water means dh dt is the rate of change of the height of water with respect to time increasing or decreasing. What that means is I'm going to have to look at the derivative of dh dt at h equals 3 feet. I already have an expression for dh dt, but I need to find the derivative of this expression at h equals 3 to figure out the correct answer. So here we go. In part B, I want to find the derivative with respect to t of dh dt when h equals 3 feet. Now, keep in mind, we already have an expression for dh dt. dh dt is negative 1 over 10 times the square root of h. And I want to find the derivative with respect to t at h equals 3 feet. So, you're going to want to be really careful here. We're taking the derivative with respect to t, but the variable over here is h. So, well, the negative 1 over 10 is a constant. The derivative of the square root of h, or h to the half, is 1 over 2 times the square root of the height. But you're taking the derivative of height with respect to t, so you have to multiply by dh dt. And then we're going to evaluate this expression at 3 feet. Okay, well, negative 1 over 10, not a big deal. H equals 3, I could plug in 3, fine. But what's dh dt? dh dt, remember, is that expression that we saw before. It's the negative 1 over 10 times the square root of h. And we're going to evaluate this whole thing at 3 feet. If I plug in 3 everywhere there's an h, we get negative 1 over 10 times 1 over 2 square roots of 3 times negative 1 over 10 times the square root of 3. Now, that is the derivative with respect to time of dh dt at h is equal to 3. The reason we did that is we wanted to know, is this rate of change increasing or decreasing? Well, look at your final answer. Negative 1 over 10 times a positive 1 over 2 square roots of 3 times negative 1 over 10 times a positive square root of 3 has to be positive. And so what that means is your derivative of dh dt is positive, therefore the rate of change of the height with respect to time is increasing at h equals 3 feet. We know that because your derivative is positive. We don't even need to know positive what, we just need to know positive. Let's look at how they awarded points. They awarded 1 point for correctly finding the derivative of the negative 1 over 10 square root of h and getting this part right here. So basically they're saying if you know how to find that derivative, we're going to give you the point even if you forgot to use the dh dt. However, if you use the dh dt, so if you made it to this point here, you remembered to apply the chain rule, they awarded a second point, and then your last point comes in here when you correctly evaluate the second derivative at 3, recognize that that's positive, and then give your final conclusion. That is your final point for a grand total of 3 points. Not bad. I would hope this is still going to be a relatively high scoring question, especially for Calculus BC students. Let's move into the final part. Here we go with part C. It says, at time t equals 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. So at time t equals 0 seconds, the height of the water is 5 feet. So the height at time 0 is 5. They want me to use separation of variables. We should be really comfortable with this process. The name says it all. You're going to go to your differential equation, which has dh dt negative 1 over 10 square root of h. We're going to separate the variables. We're going to solve that differential equation by integrating both sides, using the initial condition, and wrapping it up from there. So, here we go. Part C. We know that dh dt is negative 1 over 10 times the square root of h. And we have an initial condition that h of 0 is equal to 5. So let's separate the variables. I'm going to multiply both sides by dt. dh is equal to negative 1 over 10 times the square root of h times dt. If I've got dh on the left, I have to get the square root onto the left as well. So I'm going to divide both sides. dh over the square root of h equals negative 1 over 10 dt. At this point, I've correctly separated the variables. So I'm going to integrate on the left. I'm going to integrate on the right. You might know right away what the integral of dh over the square root of h is. I'm going to assume that you don't. And so let's do this work on the side. The integral of dh over the square root of h, that's the same thing as saying dh over h to the half, which is the same as saying h to the negative 1/2 dh, right? Just rewrite it with a negative exponent. I have h to a power. The power rule says add 1 to the power. Negative 1/2 plus 1 is 1/2. Divide by that new power. 1 divided by 1/2 is 2. To integrate negative 1 over 10 dt, that should be even easier. The integral of negative 1 over 10 with respect to t is negative 1/10 t. Integral on the left, integral on the right. I'm going to set them equal to each other, but don't forget about your constant of integration. So 2h to the 1/2 equals negative 1/10 t plus c. I can tell you right now, you have already earned a lot of points with the work that you've done. Ultimately, you need to get your final answer expressed in terms of h equals, so h by itself. We have an initial condition. I'm going to use that initial condition right now. H of 0 is equal to 5. So when t is equal to 0, h is going to be equal to 5. So if I plug that in, I'm going to get 2 times the square root of 5, h to the half means square root, is equal to negative 1/10 times 0 plus c. So 2 times the square root of 5 is equal to c. So going back to the original equation, 2h to the half equals negative 1/10 plus our c, which is 2 square roots of 5. We're going to divide both sides by 2. H to the half means square root of h. Negative 1/10 t divided by 2 is the same as negative 1/10 t times a half, so that's negative 1/20th t. 2 square roots of 5 divided by 2 is square root of 5. To get h by itself, I'm going to square, and I'm going to square. Square root of h squared is h. On the right, I'm going to say negative 1 over 20t plus the square root of 5, the whole thing squared. I don't need to simplify. I don't need to expand. All of that would be a waste of time and possibly throwing away a point. Let's look at the points here. There was 1 point earned as soon as you separated the variables. And I'll tell you, this is a really important point. If you correctly separate the variables, you get the first point. If you do not correctly separate the variables, then you are done. There are no additional points that you could possibly earn. So this first step is a really important access point. I would put a star next to it and make sure that you are always doing that. Then they awarded 1 point for correctly finding the antiderivatives. You had to find both of them. Okay, the next point comes in for the work with the initial condition and your constant of integration. Finally, your last point involves saying what h is equal to. That is your last point. This is a 4-point question. This was the greatest number of points that we've seen for any of the questions on the test this year. Separation of variables is a really important concept for you to master. This could be as much as 5 points, or I've even seen a 6-point separation of variables question. You want to make sure that you are able to rock a question like this from start to finish. That's it.